Hey everyone, and welcome to this deep dive. We're going to get into some pretty technical stuff today, but trust me, it's fascinating stuff. We're going to be looking at OpenAI's O1, specifically how it can reason like us humans.
Yeah, it's really impressive.
And we've got this paper here that breaks it all down, analyzes O1 through the lens of reinforcement learning.
Reinforcement learning, that's basically how AI learns through trial and error, right?
Exactly. Like how you teach a dog a new trick with treats. Good boy.
Okay.
So O1, it's making waves in the AI world because it can tackle these super complex problems, write code like a pro, and even solve those tough math problems that would make most of us sweat.
It really is remarkable the things it can do. Like, it's really pushing the limits of what we thought AI could achieve.
Right. It's like, is this thing actually thinking like us? The paper we're looking at today, it breaks down O1 success into four main components. And the first one is policy initialization.
Policy initialization.
Yeah, so think of it like laying the groundwork for O1's reasoning abilities. We're kind of giving it a head start in the race to, well, intelligence.
Interesting. So how do we do that? How do we give it this head start?
Well, that's where it gets really cool. We basically flood it with a massive amount of data. I'm talking about language, facts, logic, all from the vast expanse of the internet. Think of it like sending O1 to school, but at, like, warp speed.
Wow, so it's absorbing all this information.
Yeah, like a sponge.
Yeah.
And it uses all this data to build up its knowledge base, kind of like, how we learn grammar and problem solving in school.
Right, but it's happening so much faster for O1.
Way faster. But there's more to it than just cramming its digital brain with data.
Right. Oh, absolutely. I mean, O1 doesn't just passively soak up information. It learns how to use it, And this is where instruction fine-tuning comes in. Basically, we give O1 specific instructions, and examples is how we shape its responses so they line up with what we humans expect. We kind of guide it towards thinking like us.
Okay, so it's not just understanding language. It's about learning how to use that understanding to follow instructions and solve problems just like we do.
Exactly. And it's doing a pretty amazing job of it. But here's the real kicker. O1 actually goes beyond just following instructions.
Wait, really? How?
The researchers, they've observed six distinct human-like reasoning behaviors that O1 exhibits.
Okay, this is where it gets really interesting. So spill the beans.
Hmm.
What are these behaviors? What makes O1 different from all the other AI out there?
Well, let's start with the first one. Problem analysis. Just like how we might reread a set of instructions to make sure we really get what we're supposed to do, O1 does something similar. It breaks down the problem, figures out the important parts, and the constraints it has to work within.
So it's not just blindly jumping into a problem. It's actually taking the time to understand it first. That makes sense. What's next?
All right, so next up is task decomposition. When you've got a big, complex problem, what do? Well, hopefully not. O1 takes a more strategic approach. It divides the problem into smaller, easier-to-manage steps.
Oh, so like breaking down a giant project into smaller tasks.
Yeah.
I definitely do that to stay organized. What happens when O1 figures out those smaller steps?
Then comes the actual work, the task completion. O1 tackles each of those subtasks, one by one, using a step-by-step reasoning approach. It's like a little detective working its way through the clues.
I like that. But what if O1 hits a roadblock? Does it just give up?
Not at all. O1 is pretty persistent, actually. It engages in alternative proposal. So basically, if it runs into a challenge, it doesn't just get stuck. It starts brainstorming, coming up with different options to try.
So it's adapting, right? It's not just stubbornly following one path.
Exactly. It's flexible and resourceful. And get this, O1 even does some self-evaluation.
Like checking its own work.
Yep. It double-checks for accuracy, just like we might double-check our answers before turning in a test. It's got its own internal quality control going on.
So it's making sure its answers make sense.
And if O1 finds a mistake, well, it can do some self-correction, revise its approach, and get back on track.
Wow. It's like it's learning from its mistakes.
Exactly. All these behaviors, they're straight out of the human problem-solving playbook.
This is incredible stuff. It's like O1 is thinking and reasoning just like we do. Okay, I'm ready for the next component. What's next?
All right, so we've covered how O1 learns, but how does it know what's good and bad? That's where reward design comes in. We have to guide O1 somehow,
It's like setting up a point system, like you were saying earlier, giving those digital dog treats for good behavior.
Exactly. But it's a bit more nuanced than just giving it a good job sticker every time it gets something right.
So how does it actually work?
Well, the paper dives into two main types of rewards. You've got your outcome reward that's pretty straightforward. You reward O1 when it reaches the desired outcome.
Like finishing a puzzle correctly.
Exactly. But the thing is, that only rewards the end result, not all the steps it took to get there.
Right, and those steps matter, especially if we want O1 to actually think through problems the way we do.
You got it. And that's where process reward comes in. We're rewarding O1 for taking the right steps, even if it doesn't get the final answer right. It's about encouraging those good problem-solving habits, you know?
So it's not just about reaching the destination, it's about enjoying the journey, right? But where do these rewards come from? Like, are we programming them in?
Well, sometimes, yeah. For instance, if O1 is writing code, there's a clear signal either the code runs or it doesn't. That's its reward or punishment right there.
Okay, so for some things, the environment itself provides the reward. But what about tasks that are more subjective, where there's not such a clear right or wrong answer?
That's where things get really interesting. In those cases, the paper talks about using human feedback to shape the rewards.
Hold on, so we're teaching the AI what we think is good.
That's right. And that highlights the crucial role we humans play in shaping AI, especially for those tasks that require, well, let's say a human touch, you know?
This is mind-blowing. So we've covered how O1 gets that initial knowledge
Yeah.
and how it learns what's good and bad. What's next?
Well, before we move on, there's something else I wanted to touch upon. Some researchers are exploring this idea of having AI actually judge AI.
Wait, what?
Yeah, I know, it sounds wild, right? It could potentially help eliminate human bias, but it also raises a whole other set of questions. We'll dive into that fascinating debate a little later. For now, let's talk about the next piece of the puzzle, search.
Search. But I thought AI had, like, instant access to all knowledge. Why would it need to search for anything?
That's a common misconception. AI doesn't just magically pull answers out of thin air. It has to explore, evaluate different options, and basically search for the solution. It's like navigating a giant maze.
Okay, I'm starting to see the picture. So how does O1 actually search for these solutions?
Well, that's a topic for the next part of our deep dive, but I'll give you a sneak peek. It involves this fascinating combination of guiding signals and search strategies. Think of it like navigating a labyrinth with a map and a compass.
I'm definitely intrigued. This is already way more complex and honestly way more cool than I ever imagined.
Well, I told you it's a deep dive, and we've only scratched the surface of how O1 achieves these amazing reasoning abilities.
And on that note, let's take a little break. When we come back, we'll delve into those guiding signals and search strategies, and then we'll finish up by talking about the last component, which is learning. Stick around.
Welcome back. Before the break, we were talking about how O1 actually searches for solutions, which is a pretty crucial part of its reasoning process. Remember, AI doesn't just have all the answers instantly. It needs to explore, evaluate different possibilities.
Right, like it's navigating a maze. You need a good strategy to find your way out, and that's where those guiding signals and search strategies you mentioned come in.
Exactly. So let's start with those guiding signals. They're kind of like clues, right? They help O1 navigate that massive search space, give it some hints along the way.
Okay, so they're pointing O1 in the right direction. Where do these signals come from?
Well, they can come from different places. Some of them come from within O1 itself, like its own sense of uncertainty about a particular solution. That internal feedback helps it figure out which areas need more exploration.
So O1 is always checking in with itself, using its own internal feedback to refine its search. What about those external signals you mentioned?
Oh, those are just as important. External signals can come from the environment itself. Like if O1 is running a piece of code, the feedback from that, whether it works or not, that's a pretty clear signal.
Right. It's getting real-world feedback, testing things out.
Mhm.
What I find really interesting is that these signals can also come from a separate reward model.
You got it. That's right. A reward model is basically another AI system that's been trained to evaluate the quality of solutions. So it's like having a coach or mentor giving feedback to O1 and helping it learn.
So it's learning what's good and bad from another AI. That's pretty wild. Okay, so we've got these guiding signals,
Yeah.
but they're only part of the story, right?
Right. We also need some effective search strategies so O1 can actually explore all those possible solutions.
Because it's not just about having the clues, it's about knowing how to use them.
Exactly. The paper talks about two main types of search strategies: tree search and sequential revisions.
Okay, break those down for me.
Okay, so imagine a tree with lots of branches, each representing a different path or sequence of actions. Tree search is all about exploring those branches in a systematic way, evaluating different paths until it finds the one that leads to the best outcome.
So it's trying all the different routes in the maze until it finds the way out.
Yeah, that's a good analogy. One common example of tree search is what's called beam search. With beam search, OO1 keeps track of the most promising paths and then focuses on exploring those further.
Makes sense. So it's like narrowing down the possibilities, getting rid of the dead ends.
Right.
What about sequential revisions?
Sequential revisions is a bit different. Instead of exploring multiple paths at the same time, it starts with one solution and then iteratively refines it, like making small changes until it finds the best version.
So it's like editing a draft, getting closer and closer to that final polished version.
Exactly. Both approaches have their pros and cons. Which one works best often depends on the specific problem and the nature of that search space we were talking about.
Right. And earlier you mentioned Monte Carlo tree search, which was used by AlphaGo, the AI that beat the world champion Go player. Where does that fit in?
Oh, yeah. Monte Carlo tree search, that's a super powerful type of tree search that works really well for things like games, where there are tons of possible moves and outcomes. Basically, it simulates thousands of possible games to figure out which moves are the strongest.
Wow, that's a lot of mental gymnastics.
I know, right? It's like O1 is playing out all these scenarios in its head, trying to predict the best move. It really shows you the incredible processing power these AI systems have nowadays.
So to recap, we've got these guiding signals pointing the way, and we've got these search strategies exploring the options. But how does O1 actually learn from all this?
Ah, that's the million-dollar question. And it brings us to the final component of O1's reasoning abilities, learning.
All right, let's get into that. How does O1 take all the information it's gathered and use it to get better?
Well, buckle up, because this is where it gets pretty technical. The paper goes into all the nitty-gritty details of the learning algorithms, but essentially it comes down to two main methods: policy gradient and behavior cloning.
Okay, I'm ready. What's the difference between those two?
So think of policy gradient as learning by trial and error. O1 tries different things, gets rewards for the good stuff, penalties for the bad stuff. Over time, it figures out how to get more rewards and avoid those penalties.
So it's like learning to ride a bike. You fall down a few times, but eventually you figure it out.
Exactly. Practice makes perfect, as they say.
What about behavior cloning? How's that different?
With behavior cloning, O1 is basically learning from the best. It looks at the top solutions that were found during the search process and tries to imitate them. It's like watching an expert and copying their moves.
Ah, so it's learning from the masters.
Exactly. It's a really powerful way to speed up the learning process, especially when you've got access to those high-quality examples.
Okay, so we've got policy gradient, which is learning by doing, and behavior cloning, which is learning by watching.
You got it. And these two methods, they work together to help O1 become a more and more effective problem solver over time.
This is all pretty mind-blowing stuff, but I think I'm starting to see how all these different pieces fit together. We start with laying the groundwork, then there's the guidance system, the search party, and finally the learning process. It's like a well-oiled machine.
You nailed it. And the amazing thing is, it all works together seamlessly. It creates this AI system that can reason and solve problems in a way that's really similar to how we do it.
It's pretty incredible. This deep dive has been fascinating, but we've only scratched the surface of all the technical details.
Oh, there's so much more to unpack. The paper goes into all the nitty-gritty, all the challenges, all the exciting possibilities for the future.
I'm sure we could talk about this for hours, but unfortunately we're running out of time.
We are. But before we wrap things up, I think it's important to take a step back and look at the bigger picture. What does O1 tell us about the future of AI? Where do we go from here?
That's the big question, isn't it? What are the implications of having AI systems that can think and solve problems at this level? It's both exciting and a little bit scary, to be honest.
It's a brave new world out there.
I know.
In the final part of our deep dive, we're going to explore some of those potential applications and, yeah, the potential challenges too. From how it could revolutionize different industries to how it might even change our understanding of intelligence itself, O1 opens up a whole world of possibilities.
I'm definitely looking forward to that discussion. But for now, we'll leave our listeners with that thought-provoking cliffhanger. Join us next time as we wrap up our exploration of O1 and its potential impact on the future of AI. Welcome back to our deep dive into the inner workings of O1. It's been quite a journey exploring all the technical marvels of this AI.
It really has. We've covered how it builds its knowledge, how it figures out what's good and bad, and even how it sifts through a ton of possibilities to find the right answers.
We've talked about those 6 human-like reasoning behaviors, remember
Yeah.
those? And that intricate dance between guiding signals and search strategies. Plus, those 2 learning methods, policy gradient and behavior cloning.
Yeah, we've been through a lot. And keep in mind, we've only just scratched the surface. This paper, it goes even deeper into the technical nuts and bolts, you know? It highlights all the challenges and opportunities for the researchers working on this stuff.
It's been a fascinating look at the cutting edge of AI. But I'm curious, what are some of the key takeaways for us? What makes O1 so groundbreaking? And where do we go from here?
Well, one of the big things this paper highlights is the importance of computational resources. It's not just about having clever algorithms, it's also about having the raw power to run those algorithms.
So it's like having a powerful engine in a race car.
Yeah, exactly. You need a well-designed engine and enough fuel to hit top speed. The paper talks about scaling both training computation and inference computation.
Okay, hold on. Break that down for me. What's the difference?
Sure. So training computation, that's all the resources you need to train the AI model in the first place. It's like sending it to boot camp. Inference computation is what you need to actually run the model once it's trained, you know, to make predictions and all that.
So we need massive computing power, not just to teach O1, but also to let it actually think and solve problems once it's learned.
Exactly. And that brings us to this really cool concept called scaling laws. Researchers have found that AI performance tends to get better in a predictable way as you increase the computational resources.
So the more computing power you throw at it, the smarter it gets.
Yeah.
Is there a limit to that?
That's the big question. Researchers are still trying to figure that out, but so far it seems like the sky's the limit. As computing power keeps getting better and better, AI systems are only going to get more capable.
That's exciting. And maybe a little bit scary, too. Makes you wonder what the future holds.
It definitely does. Now, let's shift gears a bit and talk about some of the challenges and future directions this paper highlights.
Sounds good. What do we have?
Well, let's start with policy initialization. That's that crucial first step where we set the stage for O1's reasoning abilities. One of the big challenges here is finding the right balance, you know? Giving O1 a solid starting point, but also letting it have enough freedom to explore and come up with its own solutions.
So it's like giving a student a textbook, but also encouraging them to think outside the box.
Yeah, exactly. Too much structure in O1 might get too rigid, you know? Not creative enough. Too much freedom, and it might just get lost. Finding that sweet spot is key.
Makes sense. What about reward design? We talked about how tough it can be to design those reward functions properly.
Yeah, it's tricky. One of the big challenges is really capturing all those nuances of human judgment, especially for tasks that are subjective or require common sense, you know? It's not easy to translate that human understanding into something an AI can grasp.
So we're basically trying to teach you human values and judgment,
Yeah.
which is no easy task.
Not at all. And then you have to worry about bias creeping in, even if you don't mean to.
Oh, right. Even if we're not intentionally trying to bias the AI, our own biases might slip into that reward system.
It's a valid concern,
Yeah.
but researchers are working on ways to address this, to make sure these AI systems are fair and unbiased.
Well, that's good to hear. Okay, how about search? We talked about those huge search spaces and the need for efficient strategies. What are some of the challenges there?
Well, one is just the sheer scale of it all. Imagine searching for a specific grain of sand on a beach. It's a needle in a haystack problem.
That's a great analogy. So how are researchers tackling this?
They're coming up with smarter search algorithms. Algorithms that can really hone in on the most promising areas and avoid wasting time on dead ends.
So it's like a super efficient detective, right?
Yeah, something like that. But even with those fancy algorithms, there's always a risk of over-optimization.
What does that mean?
It means that if O1 gets too focused on maximizing its rewards, it might miss out on other, more creative solutions. Solutions that don't quite fit its current understanding of the problem.
It's like getting tunnel vision. You miss the bigger picture.
Exactly. So finding that balance, you know, between optimizing and exploring, that's crucial.
Makes sense. Okay, last but not least, we've got learning. What's going on in that area?
Well, one challenge is figuring out how to best use all the different learning methods we have. We talked about policy gradient and behavior cloning, but there are others too. Researchers are experimenting with hybrid approaches, combining the best of each method.
So it's like having a toolkit, right? You pick the best tool for the job.
Right. Another challenge is just the sheer amount of data involved. We need algorithms that can learn quickly and efficiently, even when they're dealing with a massive amount of information.
So it's not just about having the tools, it's about making sure they can handle the workload.
Exactly. And that's why there's so much research going on in this area, trying to develop more efficient and scalable learning algorithms.
This has been a truly mind-bending exploration of how O1 works. We've covered so much, from the importance of computational power to the quest for better learning algorithms. It's amazing to see how all these pieces come together.
It is. And the most exciting thing is that this is just the beginning. AI is evolving so fast, and systems like O1 are really pushing the boundaries of what we thought was possible.
It makes you wonder where we'll be in 5, 10 years from now. What kind of AI will we have then?
It's hard to even imagine. But one thing's for sure. As we keep developing these AI systems, we need to make sure we're doing it responsibly. We need to think about the ethical implications, the potential impact on society.
Right, AI should benefit everyone, and we need to use these powerful tools wisely.
Couldn't have said it better myself. Well, this has been a fantastic discussion. I hope our listeners have enjoyed this deep dive into O1 and that it sparked their curiosity about AI and its potential.
Thank you all for joining us on this incredible journey into the heart of artificial intelligence. It's a complex field, but it's also incredibly exciting. Until next time, keep exploring, keep learning, and keep asking those big questions.